So in this video, we're going to continue our exploration of programming and Python programming in particular. And we're going to we're going to start building our tool set. Okay. So what I have on the screen here is the basic outline of most programs, right? Most programs are going to accept some input or inputs. Someone's going to enter names or dates or data or whatever. The input could come from some device, a thermometer, some other kind of reader. Okay. The program will then do something with that data. Okay. If it doesn't do anything with the data, why are you writing a program? And then finally, there has to be some way to let the user know what happened. It's usually by printing it out on the screen, could be to displaying it on the screen, could be printing it out to a printer, it could be making a sound, could be doing lots of things, lighting an alarm bell, whatever it is. So that's kind of the basic structure of what we're doing. Okay. So we have some tools that we can use, and we'll develop more as we go along. Okay. And the first function, which we saw when we did the hello world. Okay. So here's our hello world. If that's still hello world, I'm in Colaboratory here. Yes, we have the print statement, right? That's our first statement we're going to use. Okay. So print is a function. We'll talk more about functions later, but a function takes parameters. The parameters are within the parentheses, the left and the right parentheses. Okay. So what we're sending to print is going to be what we call in programming a string. Okay. A string is any sequence of characters that begin and end with either a double quote or a single quote. Either one's fine in Python. Okay. So if I were to change, you can't mix them, but if I would change that, both of those to single quotes and run the program again, when it all reconnects, first time takes a while, you'll see we still have hello world. No problem. Okay. But you can't mix them. That would be a problem. Okay. And you see it's a problem right away because it's in, there's the line under it, and it says that it was not closed. Okay. It wasn't closed because it needed that single quote. So the string literal is unterminated. It says that right on the screen. Okay. Which is helpful. Okay. So that's how the print statement works. Okay. There are other things we can do with the print statement. Okay. It can get a lot more complicated than that. Okay. So whenever you need to print something out on the screen, do it this way. Okay. Not an issue. Okay. One thing to watch out for, I'll put it on the second one here in the name. I have a friend whose name is Wendell O'Brien. Okay. And he has the distinction, like many people, of having an apostrophe in his name. Okay, so if I were to enter things like this, we can tell visually something's not right, right? Because inside of our quotes, it should be this maroony brick color, okay? And it is up until here, but then it stops. And then this just sitting out there, this extra quotes out there, and who knows what's going on, okay? We see there's an error, okay? It's unterminated again. It wasn't closed, okay? So that's why we can use both, okay? So if you want to use single quotes inside of your output, you have to include it in double quotes. Okay. And same way, if you want to use double quotes, use single quotes. And if you run that, there you go. Okay. So there's some more things that we can do with print statements as we go along. Okay. But to kind of follow along the book, the next section talks about comments, which we've mentioned before. Okay. So our comments, again, just have this octothorpe or hash symbol or shift 3 in any case. Okay. And what that means is, and again, we've talked before about this is an interpreted language. So when the interpreter tries to run this language, it goes to the first line and says, what do I do? There's the octothorpe there. I don't do anything. Next line, what do I do? Nothing. Next line, what do I do? Nothing. Okay. Go down to here. Now I do something. If you have a line that's causing you trouble, but you don't want to have to retype it later until you figure it out, if you do that, now it's turned green. And when I run, nothing happens. Okay. No error, but it doesn't run. Okay. So again, for all the programs that you do in here for this class, you'll need to have a program name. You'll have to have your programmer, the program name, your name as a programmer, the date it was programmed, and then whatever notes you may or may not need. Okay. And those, again, are not in text blocks, which we have available. The text blocks are more for like bigger things. This is so you can do all of your homework assignments on the same notebook, as they're called in Colab world, where you put the name of the assignment at the top and then each one. Okay. So each sub little program. So just so we're clear, this is a program inside of this gray box. And this is a program inside of this like gray box. Okay. So this notebook has two programs in it. Okay. Just so we're clear on that. Okay. So comments, again, are useful in many situations. They're useful when we want to let other people know what's going on in our code. They're useful for us. If you look at a program later, we're not going to remember a week from now, probably. We're certainly not going to remember a month or a year from now what the code meant. Okay. And you'll also see as our programs get more complicated, I will use comments to kind of scaffold out what my program needs to do, the sections of the code. First, we need to do this, then we need to do this. Okay. And that'll be based on the algorithm and the flow chart that we talked about before. Okay. So the next concept we need to talk about, and this opens up kind of a whole issue for us. Okay. And that's there are terms in programming, in Python in particular, that are the same terms and the same symbols that we use in mathematics, but they're not exactly used the same. Okay, they have different meanings, and that can be a little bit confusing. Okay, and we're going to get the two instances of that right now. Okay, the first thing that causes a problem for us is the term variable. Okay, so a variable in mathematics can be defined as an unknown. Okay, that is not the case in programming. In programming, we often know what the value of a variable is. Okay. A better term for variable is label, but books don't call them labels much. I probably won't call them labels much. Other programmers don't call them labels. They call them variables. But keep in mind, this is different from a mathematical variable. Okay. So when I say that it's a label, what I'm meaning is, okay, we have in our computer memory. There's memory out there. Okay, it could be a bunch of it. And let's say I want to draw a bigger box. Can I draw a bigger box? Maybe. Kind of make this box bigger to include all of that. Now it's hidden, but we'll figure it out. Okay, so let's say this is memory. Okay. And then in that memory, we're going to store a string Bob. Okay, make it a little bit smaller. Bob didn't need that much room. Okay. But Bob over here in memory. We somehow have lost Bob. Okay, that must be, can I move this to the back? Should be a way to do that, to bring to front. Oh, let me do that though. No, send it back. There we go. Okay, now we've got it. So now we don't do this ourselves, especially in Python. But when we create a variable, we create a spot in memory to hold that information. Okay. And then we create a variable like name. Okay. What that name variable really is going to be a label for that memory address. Okay. So when I say print name, it's going to print Bob. That's the current location of that box. Okay. If I change the name, let's say he gets a promotion, wants to be known as Robert. Okay. Name now refers to Robert. Okay. So the variable doesn't refer to what's in it, it refers to where it's at. Okay. So a variable could be like a house address. Okay. It always points to the house. What's in the house? Who lives there? It varies. Okay. So that's the idea of a variable. Okay. And not exactly like it is in mathematics. So how do we declare variables? Okay, we'll go back over and get us a new program. Okay, so go back to here. Again, I'm going to say new. I'm going to say more. I'm going to say Google Colaboratory. Again, if you don't have Colaboratory, you have to go down to connect more apps, look for Collaboratory, and install it. Okay, once it's there, sorry, it's allergy season. I now have my code here. So I'm gonna go ahead and make a comment, fun with variables. Okay. Again, I'm not gonna add the program block because I'm just messing around here, but in general, you should put your programmer name, program date, notes, all that stuff. Okay. So when I create a variable such as name, I'm going to use the assignment operator to assign a value to that. Okay. I want it to be the string literal or the string. Yeah, it is a string literal Bob. Okay. So when you see that, you may read that as name equals Bob. I'll probably say that as well, but that is incorrect mathematically. Okay. A single equals sign, and it still is called the equal sign, in Python is the assignment operator. So what the correct way to read this is that name is being assigned the value Bob. Okay. When we get to equality later, testing equality, we're going to use two equal signs for equality. So there's a difference. Okay. But we don't need to get into that now. Okay. So I can say name is equal to Bob, and now I can print out that name. Okay. Let's run that, see what it does. Prints out Bob. Okay. Note, I don't need to put it in quotations. If I do, what's it going to print out? It's going to literally print out the word name. Okay. That's what it did. So I want there to have it print out just the variable name. Okay. That variable name is changeable. If I say name is equal to Alice and print out the name again, prints out Bob, Alice. So as we're interpreting, it ignores that line. It's now assigning the value of Bob, the string Bob, to name, printing that out. So it's Bob at this point. It's now reassigning, okay, the name Alice to the variable name, or the string Alice to the variable name. It's then printing that out. Okay. So you can create variables in this way. Okay. So this leads naturally to the idea of what types of things can we put into variables. Okay. So I could, for example, here say name is equal to 15. Doesn't make a lot of sense, but the computer doesn't know that. Okay. So now it's 15. Then it's Alice. Okay. This points out something about Python that's different from other languages. In particular, it's different from C++, which is the next language you learn in our program. Okay. Python is what's known as a loosely typed language. Other languages, when you create a variable, you assign it a type. It has to stay in its lane. It's always that type. It's not true here. Okay. In fact, there's a type command that can show this a little bit, a type function. Okay. Type takes the word name. Okay. It's going to print out that we have type name there. That may not actually print that out. Let's see what it does. It does not. Okay. So what I need to do. So instead of doing it this way, I'm going to print out name, comma, type name. Okay. So something else we can do with our print statement, which we didn't talk about, we can print more than one thing. Okay, separated by commas. Okay. And a space there would be nice. Spaces don't affect the program at all. This makes it easier to read. Okay. So now this returns the name, which in our first case is oddly enough 15. It then puts a space in there. The comma puts a space automatically. And it puts in the type of name, that name variable. The type of the variable at that point is an int or integer. An integer is a number with no decimal portions or no fractional portions. Whole numbers, counting numbers, whatever you want to call them. Okay. I guess whole numbers would be more correct. Then we change the name to Alice. Now that's a string. Okay, so it returns the class as str. Now it's a string. Okay, and that's okay. You don't have any issues with that. That's perfectly fine. But while that is good, good in some ways, it's bad in some ways. You now have to make sure that your variable is the correct type whenever you want to do something to it. Okay, because if I try to add something to name when it's an integer, we're good. If I try to add something to name when it's not an integer, when it's not a number like a string, that could be a problem. Okay. So some other types we have here, we have, if we have a decimal type there, that's one thing. We'll run that. We're going to call that a float. It's a floating point number. Okay. The other thing we can do is we can have a Boolean. Okay. And that can be equal to true or false, and only true or false. Okay. So now, note there are no quotes around that. True is something just, it's a reserved word, it's a concept. Okay. So we now have our data types we're going to be using for the most part. We have integers, we have floats as the two numbers we're using. Integers don't have decimal places, floats do. Okay. We have strings, which is anything enclosed in quotes, either single quotes or double quotes. And then we have Booleans, which are either true or false. Okay. So as far as what you can name your variables, okay, there are some rules. The first rule is that you can't use any of the Python keywords, and that was back in table 1.2 in the textbook. Okay, a variable name cannot contain spaces. Okay, so that leads to a interesting point of contention among programmers. So there are two ways to show that there should be a space. Okay, I can do it this way, last name. That's perfectly okay. Okay. Well, there's an issue now. Note that as soon as I did that, the name in the print statement below it had an issue. So there's an issue here, but there's not an issue here. And that's because the last name has not been defined. Name has not been defined here. Last name has, but not name. But we do define name there, so it's okay. Okay. So that's one way to do it. And that's probably the preferred way. But I'm a fan of what's called camel caps. Camel caps looks like that, where every word of the variable or the whatever else we're doing, class, function, anything, is capitalized. Okay. So either of those ways works. That way does not work. Okay. So those are your variables as far as you go on naming. Okay. The first character has to be a letter, either lowercase or uppercase. Okay. Or an underscore. Okay. So I can say name 2, life's good. I can't say to name. Okay. See, that gives me an error right there. Okay. So that doesn't work. Okay. I will say underscore is okay, but underscore typically in Python has special meaning. So in general, don't name things as underscore. Okay. After you do your first letter, okay, you can do whatever you want. Okay, as far as letters go. So you can do letters, digits, or underscores, but you can't do, I can't do name. That doesn't work. Okay. But I can put numbers or whatever I want there. Okay. It's important to realize that uppercase and lowercase are not the same. They're distinct. Okay, so when I do this, I now have an error. Okay, name with a capital N is not the same as name with a small n. Okay, and that's true of most programming languages. Okay, so when you're naming your variables, you want the name to be meaningful. So when you're reading it, you can make sense. It makes sense to you. You know, everything shouldn't be X, you know, or Y like we do in math a lot. Okay, but at the same time, you don't want it so long that it becomes cumbersome to type. Okay, so you'll get a feel for how you want to name your variables, but the variable should say something about it. Okay. So another example the book gives, we'll just go ahead and type it in verbatim here. Okay, so we're setting a variable room equal to 503. Okay. So room's now an integer. Note that my output doesn't change until, no, I can kill it if I want. That's fine. Okay. But if not, it saves to what it was last time. Then I'm going to print. I can do multiple things. Again, I can connect them together. I can say, I am staying in room number, comma, room. Okay. If I run this, we're good. Again, the comma automatically puts a space there. Other languages, particular C++ does not. C++ would have to look like that. We don't need that. Now, if I do that, it's going to space it one over. Okay, so it takes that space and literally puts it down there. Okay. Again, I can reassign my variables as much as I want. There's no problem with that. Okay. So, yep, not any issues with that at all. Okay, we can set it to a different type and we're good. Okay. So I think I said I'm going to go up through section 2.5, but that's incorrect. I'm going to go ahead and cover section 2.6 in this video as well. Okay, so in addition to the outputs, we're also going to talk about reading from the keyboard. That's an important thing. Okay, so we're still in this idea of we're going to input something from somewhere. We're going to process it and we're going to display it. Okay, we're not doing much processing yet, but we're getting the other things. Okay, so let's say here, instead of typing the number in directly, okay, which would be of limited usefulness, let's instead say that we're going to ask the user. Okay, so I'm just going to get the basic form here. We're going to say the variable name is equal input, it's going to be our function, okay, and then some prompt. Okay, that prompt is typically a string. Okay, so I can do something that I give the user an idea. So I can do something like name is equal to input. Okay, and note that input turns kind of a khaki color, at least on my computer, which means it's a function. Then we get our blue lines, the blue parentheses. When I put the first one, it does the other one. It also gives me kind of an idea of what's going on here. Okay, so again, the prompt is going to be a string typically. I can say something like, what is your name? Question mark. Okay. That's it. And then I can print out name. Okay. So what's the name going to be? Well, we don't know, right? We don't know until we run it. Okay. So we run it. Now, for the first time, it's going to ask us, what is your name? Okay. Type in David. Hit enter. Not what I wanted. Hit enter. And it prints out that name. Okay. So one thing I note there, stylistically, need a space there, right? Just to make it look a little better. Okay. And just printing the name is kind of silly. So let's go ahead and say, hello, name. Run it again. That spacing looks better. Let's say Bob. Hello, Bob. Okay. So one thing about the input command or the input function is that everything that you do with it is going to be a string. All the input are strings. Okay. So for example, let's change this program to say, how old are you? Okay, so we're going to have an age question. I could have added that to it. We didn't. Okay, and now I want to print the age and the type of that age, of that variable. Okay, just to see. Okay, so you run this. How old are you? Let's say we are 22. Okay, 22 is fine, but notice it's class string. That's a problem, right? If we wanted to, and this is kind of a preview of coming attractions, if I wanted to say age is equal to age plus 10. Okay. And then I want to print age. I run it. We get an error. Okay. And the error says here that we're trying to concatenate. When we concatenate a string, we just add another string to it. We can only do that to a string, not to an int. Okay, so that's the issue. Okay. So, and again, don't worry about the math I just did. We'll talk about that in the next video. So what I can do here, once I've created my age, I can say age is equal to. I'm now going to do what's called a data conversion function. Okay. So I'm going to take whatever I can, now not everything will convert, in age and convert it to an integer. Okay. So as we're going down again, the program, let's go through the way it works here. We start comment, ignore, blank line, ignore. Age, new variable, equals to input. So we're going to display on the screen, how old are you? We're going to wait for the response and the enter. When we get the response, we're going to print out that age and its type. Probably don't need that anymore, but we still are. Okay. We're then going to convert the string that always comes from the input, it's always a string, into an integer. We're then going to add 10. We're then going to say in years, you will be age. Okay. Now we can go ahead and get rid of this print because we don't care anymore. Well, no, yeah, we do. We don't care. Well, actually, we care more. Sorry, getting confused. It's early. So let's go ahead and see what this does by printing the statements out. Okay. But something else here a trick that I always use. Okay. This is something I don't really want to know, right? I'm testing this out. So I put something goofy that I will be sure to remember to get rid of. Okay. So I want to show here that it was a string and now it's an int. Okay. So I'm going to go ahead and run this. Now, how old are you? 22. Okay. So you see the first line, it's a string. And then after converting it, now it's an int. And it works correctly. For 10 years, you'll be 32. Okay. Now, what if I enter 22.33? What happens? Okay. Doesn't work. Got a problem. The problem is, and if you look, it points, the green arrow points to exactly where the problem is. It's on line 6. I'm trying to convert 22.33 into an integer. Can't do that. Okay. But I can convert it to a float. Okay. If I do it now, enter 22.33, and you'll see that it was a string. Now it's a float. And now in 10 years, it'll be 32.33. Okay. So that all works. Okay. So that allows us to get information from the user and input it correctly. Okay. So what we tend to do instead of this two-step thing, instead we can do it all in one step. Okay. So that's the next example we're going to do. This will be the final example of this video. I know this is a longer video than normal, but it's important stuff. Okay. So on this one, and again, I'm going to go ahead to avoid confusing us. So in this program, we're going to get the user's name, age, and income, let's say. Okay. So I don't really need to do much of an algorithm on this because I'm not doing anything with it. So this is pretty straightforward. Okay. So I have name is equal to, it's just a string, so I can say input. What is your name? Question mark. We know we need a space there. Okay. And say age is equal to input. What is your age? Question mark, space. I can say age is equal to int age. Okay. All that should work. Okay. But what we can do, The int function takes anything that evaluates to something it can convert. So to a string that has just numbers, okay? For example. So I can put the int up here. So I'm going to put this whole thing inside of an int. Okay. So let's see how the program's going to deal with this. Okay. So again, we're going to come down line 1. Okay. It's a comment. We ignore it. Comment, ignore it. Blank line. We ignore it. We now have a variable called name. We're going to display on the screen, what is your name? And when they type in something, we're going to assign that to name. Okay. We're now going to come down into here. Well, it sees the int, but then it sees something inside. So it's going to keep going. Okay. It doesn't do anything with the int yet. It starts on the innermost thing. So it's going to say input. Okay. So it's going to put on the screen, what is your age? It's going to return that as a string, quote 22. Okay. That quote 22 is then sent to int, converted to an int. Okay. So this way we've done both in one line. Either way is okay. I'm not going to take points off either way, but this way makes more sense. You know, I think it's easy to deal with. Okay. And with the income equals, let's do a float on this one. They may want to put a decimal. Okay. I'm going to put, what is your income? Question mark, need our space. Okay. Need another, wait, that goes there. Need one more of those. Yes. Okay. Nope, I'm missing something. Float input. Okay, let's skip on that. Here's what I normally do, and that's why I messed up. You gotta find your own patterns. Okay, I'm gonna start with input. That works. I can then do a float that and that and get it to work out. Okay. And now if we print these out, we can print name, comma, age, comma, income. It's not pretty, but you know, it gets the point across. Okay. Run this, make sure it works. What's your name? Name's Bob. What's your age? 22. What's your income? Okay, note, I cannot put this. Okay. Several problems. The decimal point's not a problem. That's good. And notice that my little wheel is turning because the program's still running. I can't put the $sign. I can't put a comma. Okay, but I can do the rest of that. We print it out. Bob 22, 23, 000.44. Okay. We have some options on printing things out a little bit differently later on, but that's the basic idea. Okay. So we've covered the basics of input, processing, and output, the basics. So the next step we're heading toward, if you want to move ahead, is how to perform calculations. That'll be our next thing that we can do. Okay. And again, there'll be some differences with how it relates as opposed to how math works. Okay. So if you have questions, make sure you let me know.